prism glasses. They actually function like prisms. And you know that a prism will take white light and separate it into the rainbow. Well, those glasses do much the same thing. They have plastic, and the plastic has little etchings on it, lines very close together, so it functions just like a prism. And I'm going to turn the lights out so you can pick out a light and look at it, and you'll say, ooh, put the goggles on. And you see the rainbow, the Roy G. Biv?
Yeah.
Sure, and that's because white light is coming through. Now I'm going to inch my way over here as best I can. Ow. And I'm going to try and find the, closer to the table maybe. Here it is. Found it. And there you can see the neon, and you see lots of different colors now, right? You see a number of reds. You have the glasses on. You need to have the glasses on. You see a lot of reds, and you see a few oranges, maybe a green or two. You see a couple blues, and all of those lights come from electrons in the neon that have absorbed energy from the electric field that I'm passing this through, and are moving to a higher energy level and then dropping back down. You may recall structures of the atom with the nucleus in the center and rings of electrons around it. And if you can imagine that, the electrons are jumping from they're absorbing energy and jumping from a low energy level up to a higher energy level. And then they drop back down. And when they drop back down, they don't have mouths. They can't scream as they drop back down. They emit their energy in the form of light. If you would look this way for a moment. Hang on. Look this way.
Oh, thank you.
Try that again. I'll put this on Ed line. All right. There we go. Well, every one of those colors that you see is a result of electrons in neon in this vacuum tube, which has neon sparsely populated in that tube. The neon moves from one energy level to another energy level and drops back down. And when it drops back down, it gives off that light. And all those colors blend together, which is why eventually we see that orange colored light. You see predominant red bands and orange bands in neon. Now neon's kind of a complex atom. It's got 10 electrons. I'm going to choose a simpler atom, the simplest atom as a matter of fact, which some of you might recognize as hydrogen. And I'm going to put a hydrogen tube in here. And when you look at that, you're going to see a pattern of Roy G. Biv because of ambient light coming through the door, but you'll see bright lines in there. Don't you see a red and a turquoise and maybe a purple? And the purple looks kind of broad, and to some people with either good equipment or really acute eyesight, they'll actually see the purple as maybe 2 lines. And what those colors that you see are is a result of electrons that have been excited, going up to a higher energy level, dropping back down from energy level 6 to 1, 5 to 1, 4 to 1, or sorry, 5 to 1, 4 to 1, 3 to 1, and 2 to 1. The red is from 5 to 1. The turquoise is electron dropping from energy level number 4 to 1. And the 2 purples, 3 to 1 and 2 to 1. So we're seeing energy emissions as those electrons jump back and forth through this system. We used this to dissect the atom and learn more about its structure back when we did atomic structure. Now you might be thinking, all right, that's all well and good, but how does that apply to people's real lives? Well, it does because...
Attention parents, this concludes period 6.
Because
please proceed to period 7.
if you were to look at bolts of energy coming through the sky at night, those bolts of energy that accompany thunder, they're accompanied by thunder, lightning, goes through the sky, and it doesn't excite neon, and it doesn't excite hydrogen. Instead, it excites the predominant air in our atmosphere, the predominant gas in our atmosphere, which starts with an N. Nitrogen. And nitrogen glows the color that you see around the lightning bolt at night. The lightning bolt itself is white, but you look at the color around it, and it's blue. You see that blue color, which is the color that nitrogen glows. So we can begin to explain lots of natural phenomena using the chemistry that we do in here. Okay? If you have any questions, you feel free to call. You're welcome to come in, visit class once in a while if you want. Feel free to call, and if students are having some difficulties, please encourage them to call. Okay? Thanks for coming.
Thank you.